try, you implement the one with a new array, and yeah, just write the code. Go ahead.
Okay.
So, does it look fine to you?
Yeah, it's fine.
So yeah, I'll try to run tests. Okay, so to run your tests if you're fine with it.
Yeah, it's fine. All the test cases are passed.
Okay, good. Yeah. So I guess we can swap the rules.
Yeah, so I can't think of an efficient way right now, but
Yeah, it's fine. It's okay. So I'll share the solution with you, like the more efficient way in which it does it in the same, and you can do it in the same array without creating a new one.
yeah,
So this is one solution.
yeah, sure.
Sorry, this is not the one. Yeah, different one. So basically, what you can do is like you can maintain a write head and read like 2 pointers basically. So whenever you don't encounter a 0,
Yeah,
you move ahead the read head. But if you when you encounter a non-zero element, you write it at the right head and then increment the right head.
okay.
So you can just copy this code and look at it afterwards.
Yeah, sure. So
Copy it, yeah, and then we can swap the roles and
yeah, I have copied it.
sure. I'll swap roles now. Yes. So like it's a like I have to search the element in this array
Yeah,
and output the index of it.
yeah, that's the question.
Yeah, and like if it has been a simply sorted array, then I could have simply applied binary search.
Yeah,
But since it is a bit shifted, then I have to do something else. Like if I simply traverse the array completely, then it's O of n. That is like brute force and linear search.
the
So-
binary search one was
so-
good. The approach was
Yeah. So for binary search, better than O of n, then O log of n will be the case, and I have to modify the binary search in some way so that I can find out the index. So
so
first I need to search for the pivot element where the array, like in this case in the given example 17, 2. So 2 should be the pivot element where the index array starts, like the actual sorted array starts.
yeah,
So I need to find out where that element is, and when I find it out, I'll check if the element is less than the 17, like the largest element which is just before the pivot element. If it is less than that, sorry, yeah, no, that will be wrong. It will always be less than that. So I can,
do you think that binary search is always applicable when the array is sorted, or you can use either way out, like if it's not sorted? Is there?
yeah, for binary search is only applicable when the array is sorted. It's not applicable when it's not sorted.
Think of any library you can use.
Sorry, what sort of library? Like search function. Like
Yeah, the binary search function. It will give you the index. But anyways, you can always check for the if the array is sorted or not. Then you can apply the binary search by hard coding it.
sorry, I didn't get your point.
Like if you know the function which can return the index where it is the 2 is right now.
Mhm.
So there is a function in the STL, C++ STL.
Mhm.
So if you know the function, then you can either write that or you can implement right now. That is the most efficient way. Or you can use the linear search. Anyways,
Okay. So what is the complexity of that function that you are suggesting?
Yeah, that will be log of n, the same as binary search.
So how will it do that? Like what are the internals of it?
Yeah, there is a template, the C++ template available in the library.
No. Like how will it do it in O log of n?
It will. I haven't read the entire code of that function, so it just return the index where it is. The normal.
So-
Yeah.
So I guess like the function that you are suggesting, I guess any if the like in this example, it is somewhat sorted. It's not completely sorted, but it's a shifted sorted array, right? If the array is not completely sorted, do you think the function will still give the answer in O log of n? Like let's say a completely random array, like we had in the previous example. Will the function still return a response in log of n?
Yeah. In the big O of n complexity, it will be a log of n, I guess. I'm not sure, but there will be some constant time also applied.
So I guess only a sorted array can be searched in log of n. Like if the array is completely random, you can't search for an element in log of n. Like how will it happen? You have to go through the complete array. You don't have any information about if it is towards the left or towards the right.
Like if we think of naive solution with the function do, actually is it creates another array and then the sorted one of it, and then search for the value and matches it with the original array where the index is. So I guess that the function does. And
So you mean you create a sorted version of that array. So if you create a sorted version of that array, then the time complexity increases to n log n.
yeah, but the space
then-
obviously increases also.
Yeah, so that is not efficient, right? Time complexity has increased to n log n.
Yeah, the time wise it is.
So what I can do in this one, in this this discussion we are looking for right now, like I have to search for the pivot first, and then consider like in case of 2, the pivot is the element that I'm searching for. Then the answer will be like straight. Like, but if it was 4, let's say,
Yeah,
then I'll look for. Basically, I'll search in the right part if it is less than the rightmost element, and I'll search in the left part if it is greater than the leftmost element.
yeah.
So I'll try it out. So first I'll try it the function you suggested.
Yeah, sure, if you can find it out on the internet.
I guess it was like something like that. Right? So does it look fine?
Yeah, I don't remember the function, so you can check on the test cases.
Yeah, I'll just try it out. Okay.
No conversion. Maybe if that you are returning a IT variable which is that
Value at IT.
it is int, right? Or it is a
It should.
pointer.
So I am returning a value at IT. Pointer is IT,
Yeah.
and I am returning the value at IT.
Can you just first code the brute force method which you were suggesting, like the previous search one, and then check for the abstract way?
So I'll not do like the linear search for the pivot. I'll do the binary search for the pivot,
Yeah, sure.
and then
Go for it. So the binary search one is working.
Sorry?
Yeah, it's working. Binary search.
Yeah, it's working. Like I need to try a few more test cases before I'm sure.
Yeah. I don't know. There might be this problem.
Hello?
Yeah.
Yeah, it works fine now. Yes.
Great. So shall I share the code?
Sorry?
The pseudocode. Shall I share the pseudocode or you?
Sure, you can share it.